Hey everyone, welcome back to the channel, and today we are going to solve a problem chunk array. And the problem statement is saying that given an array ARR and a chunk size and return a chunked array. And what a chunked array is? A chunked array contains the original elements in ARR but consists of subarrays each of length size, and the length of the last subarray may be less than the size if ARR.length is not evenly divisible by size. And it is also saying that you may assume that the array is output of json.parse. In other words, it is a valid JSON, and we have to solve it without using lodash_chunk function. And first let's understand what the example is. So basically we have given an input as an array and a size, and we have to output the splitted form of this array into each element will be subarray of size, this size which is given in input. So let's take the first example. Let's take this second example. So basically we are given this array and a size which is of length 3. So we have to perform an operation and returning output which consists of each subarray of size 3. So what will be our result? So our result will be array of array, and it contains subarray of size 3. So first these 3 will be our first element of our result. So 1, 9 and 6, and next element will be again it should be size 3, but we don't have 3 elements left, so it will be 3 and 2 in this case. So we have to return this result. So first how will we do that? So our approach will be quite simple. Just we will start iterating with I equals 0 and 0 to size, the size of ARR which is ARR dot length minus 1. Here the length is 5, so we'll be iterate to 0 to 4, and for each iteration we will just take these 3 values which is of size. So for each loop we will start from j equals 0 to size minus 1, and let's create a subarray and push subarray dot push ARR j plus I, and run this loop till I plus j is also less than this, which is, let's say, n, where n is array dot length minus 1. So yeah, and finally return this which is result here. So hope you get the intuition behind the problem and what we have to do. So let's code our solution. Let make a variable n which will be, yeah, now it's fine. Let's make a variable n which is equals to ARR dot length, and let also create result which is now an empty array, and now iterate over the array. and now push the value inside. Let's also create subarray which is now empty, and move it to the upper block. And now push arr j plus I in our subarray, and finally this dot push our subarray, and finally after this loop return our result. And now let's run our code. Yeah, this passed, and now I'm commenting this, and we can do something similar to this in other way. So let's do this. Here in the previous solution I was iterating over the array, and also inside this for loop I was also iterating over the size 0 to size, and also till j plus I is less than n, because we don't want to exceed our array. So what optimization we can do here? So we can just create our subarray here, and remove this block and check if our subarray dot length is equals to size or eyes equals length, which means if we have stored the subarray of size in subarray or we have reached till end, then we want to push inside our result. And also empty our subarray. And finally we are returning our answer here, and this should also work fine. So what the mistake here? Mistake here is I am doing I plus plus should be done here, because we are going through each element in this loop. And also I missed subarray dot push array ith element here. Here it should be n minus 1. We are checking I equals n. If I is equals to n, which means 5 here, then it is already exceeded our array. Then it should be 4, which means the last index. That's why our solution was failing here. Yeah, now it's working fine. So let's comment down this also. And the third code, let's see in the third code. And now let's see the third approach. In the third approach, we will use array.slice method. And if you don't know what the slice method is, you can read the documentation. Basically, it will give us the part of the subarray which is specified by the starting and excluding the last index. So if we want to get these 3 subarray, we can pass array.slice 0 and 3 here. It should give 0 to second index 1, 9 and 6. So let's do this also, and for this I will also copy and paste this entire function. And let n equals array.length. Yeah, this will work, and we don't need any another subarray. And and removing this block also, and just I am iterating over this array, and then I will do result.push, and what we are pushing, we will push array dot slice, and the first index will be I and the next index will be minimum of I plus size or n. And why we are doing this? We are doing this because, and this would be I plus equals size. So first I is equals 0, and then we will push back array dot slice. First index is 0 to mat dot minimum, which is I plus size. Size is 3 here. So 0 to 3 or n, and the n here is 5. So what is the minimum of 3 and 5? Then it is absolutely 3. So we will get 196 in our, it will return 196, and we will push 196 in result.push in our result, and then I will set to 3 here, and again in the next call I is 3, so array.slice will be called for 3 plus what is size 6, then it will be called 3 comma 6 mat.minimum 6 and 5. So this array doesn't contains 6th element, so minimum will be in 5. So we see that the slice method return the subarray of size 0 to end minus 1. So end here will be minimum of these two, and the minimum of these two is 5. So 3 to 4, and which will give us 3 and 2. So this should also work fine. Yeah. And now let's discuss what the time and space complexity of the above solutions. So for the first solution, we are iterating over the array in this loop, and inside each loop we are iterating over till size. So we can say that this is approximately big of n, and for every big of n we are doing big of size. So this will give us time complexity of big of n into size, and space complexity here will be, result will be maximum of size of the length of our ARR. So space complexity is also big of n, and we are also using some extra space for our subarray here. So yeah, that is linear also. And for the second approach, this one, we are iterating over the array, and it will give us big of n complexity, and we are not doing any extra iteration inside for loop. We are just checking if subarray.size is equals size or I reaches the end, which means last index. Then we pushed our subarray inside the result. Otherwise, just push inside subarray and look for if its length is same to size or not. So the time complexity here is absolutely big of n, and space complexity big of n for storing our answer in result. And for the last case, we are also iterating over the array, and then slicing array elements of size, and then storing in result. So time complexity will also be big of n, and space complexity is big of also n. So hope you guys understand this, and if you really like this video, please give a like and also subscribe to this channel. And yeah, that's all for this. See you in next video.